Okay, center. So I had 20, and so the first thing I did was I graphed f of x, which is just x plus 2, and that's simply just y equals x plus 2, so that's the first line right there. And then for the transformation, I picked 3 points from the original line, so these are my 3 points right here. And then I did the transformation, so the x minus 2 in the transformation means just x plus 2, so I added 2 to every x from the original points, and then I just simply graphed the line from the second line, which is the bottom one.
So even though it appears to look like it goes down, so like visually it looks like it's moving down, but if you look at his x values, so his x value originally of 2, 2, or is that a 0, 2, so that's a new one. So here's his 0, 2, it has moved right to 2, 2, and then his 1, 3 has moved right to 3, 3. So the y values aren't changing, but it's the x value that should be shifting right. So those x values are changing. Any questions with 20? Very nice, Tyler. Good. Very nice, Tyler. Thank you. So you should have still had a line there. It's just that line had shifted to the right. So it had the same slope. The y values are the same. It was just shifting. The second one Kate has, which again, you're creating a line. So it's the same line that Tyler drew, that y equals x plus 2. So you're shifting that line. Sorry.
You're fine. Okay, so up here, this top graph is the x plus 2, which is like the original function, and the points. And this, you see it? This is the new function we are given, and this is what it's going to do to the original graph. So it'll move it right 1. It'll move it up 3 on the y-axis, and it'll flip it because the f is negative. And when you plug the points from the top values into the new function, you'll get these. And when you graph it, the green line is the x plus 2, and the other line is the negative f of x minus 3 plus 1, or minus 1 plus 3.
This
24.
is number 24. Let's get this unzoomed and go back to your. See if we can fit both of them on. So the original graph is y equals x plus 2 or f of x equals x plus 2, however you want to think about it. She has that original graph drawn there. And the points. So you pick 3 points from the line, just like Tyler did. So Kate chose 0, 2, 1, 3, negative 1, 1. And then you're applying the fact that it moves right 1, so that's the x, and she has x plus 1. That's what it means if it's moving right 1. It's going up 2, so that's why it's y plus 2, but then the y is negative because it's flipping. So you're making the y values negative first, and then adding 3 to it, not plus 2, plus 3. Yeah. So look at her new y values that she has. So you take the original y value, you make it negative, so that 2 is now negative 2. You add 3 to it and it becomes a positive 1. So make sure anyone have questions on that? So when you're creating these, instead of trying to just draw another line, I really want you to focus on making a second t-chart. So that second t-chart, visually, it gives you points to graph so that you know what your new points should look like. And you have like a little rule to follow that's on the top of the t-chart, so you know that what is happening with your x and your y values. Any questions on that? Virginia? Yeah.
Yeah. Like I said, the green one is the x plus 2.
So if it was a positive slope, the slope is now negative because it's flipping. And they actually do intersect as well.
Sam, did you have a question too?
Yeah. So it says let f of x equal x plus 2. And I was like really confused by that.
That's like the parent function. So that's what all the graphs that are the 6 graphs are gonna like relate to or be different from.
Oh, okay. I was confused. I thought when you do like y equals x plus 2 minus 2. I was like,
So yes, you can always do that. Nice, John.
Thank you.
So, before we move to the book, if you look at questions 25, 26, 27, the little word problem at the bottom, just want to talk about that word problem. So, this word problem should be a V because absolute values are in the graph. So, the front page would have all been V's. And then this one here is a V as well. Where is the highest point of the V? Or where's the vertex? Page?
5, 120.
Yeah, so the vertex is at 5 and 120 because the graph is moving right 5 and up to 120. So your largest or highest point on the graph would be right here. Is this graph going up or down? Down. How far is it moving down each time? 15. So each time it's going down 15, that's the slope. So if I start at 120 and I go down 15, I'm at 105. Down 15 more, we are at 90. So each time I just graphed like left and right at the same time. So if I'm down 15 more from 90, I would be at 75. And then I would be at 60. And over here, 60 minus 15 is 45. If you continue that, so 45 minus 15 is 30. 30 minus 15 is 15. So I just subtracted 15 each time as I was moving down. That's what my graph would look like. Each one of those points represents the slope decreasing by 15. For number 26, it says, what's the maximum numbers of sales recorded in 1 month? So somebody has a boat company, and they're selling boats. What's the maximum number of boats that they're going to sell for a month, Caitlin? 120. What month does that happen, Caitlin? May. So in May, this company is selling 120 boats. Why is it May, Caitlin?
Because it says in the top paragraph that January's
Yeah, so if you read through the question, it says that T equals 1 represents the month of January. So these represents the months of the year. The 5th month is the month of May. So in May, we're selling 120 boats. Why would you sell a lot of boats in May? Isabella? Yeah, it's like the start of summer and everybody wants to be, I guess, on a river, in a lake. Kate?
So if January is 1, then what would the 0 be?
Yeah, maybe it really wouldn't be, because you couldn't say it was from the previous year, so just the y-intercept, kind of like that best fit line. Yeah, it would not be a month. Because, I mean, really, you can't even start out at selling 42 boats. Like, that just doesn't happen. Or 45. The last question, what's the minimum number of sales in 1 month? So which month has the least amount of sales? Aaron?
was it December?
December has the least amount of sales. And do you know how many boats were sold in that month? 15 boats. Now, if you visually cannot look at that and like know that it's 15, I actually went through and counted with you. But first find the month. So we answer the second question first. And what month is the minimum reached? Well, it's reached in December. I can take the equation and plug a 12 in. So in the 12th month, it should be a minimum value. So if you were asked to show some work here, or to algebraically find it based off of the graph, I would plug in the 12th month for t, because on my graph it looks like it's the 12th month, but it's the lowest value. And then I can solve that algebraically. Questions?
number
22 from the homework. Right, the worksheet, sorry. Yeah. All right. So number 22, I'll draw my original line. So the original line started at positive 2 on the y-axis, had a slope of 1. So here's our original graph. And we'll make a t-chart, just picking a couple of points. So I could choose negative 2, 0, 1 in the middle, and maybe 1, 3. So Grace, what does the 1/4 do to the graph? Right, I'd multiply it with my y value. So I'm taking 1/4 times y. Anything outside of the function always affects y. Whatever's inside the parentheses changes x. So as a rule of thumb, if it's outside, y is changing. If it's inside the parentheses, x is changing. So x doesn't change because there's only an x inside the parentheses. The 1/4 is on the outside. So my x values are going to stay at negative 2, 0, and 1. My y values I'm now multiplying by 1/4. So 0 times a fourth stays at 0. I have 2 times a fourth. What's 2 times a fourth? Aaron? 1/2 or 0.5. 3 times a fourth is, Aaron? 3/4, 3/4, or 0.75. So this is 0.5, this is 0.75. So they're pretty tiny numbers that we're graphing. So at negative 2, we're still at 0. At 0, we're up to 1/2. And then at 1, we're up to 3/4. So it is not a very steep line. So visually, the line, it does look like the slope has changed, but it should change because I'm rising 1 and going over 4. But it also has shrunk vertically, so it's not as steep. It's got squished down. So that would be considered a vertical shrink. Questions? How about from the book? Are there questions from the graphing problems in the book that you'd like to go over?
Were the first two questions the same ones we did in the packet? Because
Were
whenever
they
I
the
looked at them,
same?
they would be exactly the same.
I don't know. I could tell you. Maybe.
Two of them were.
The first.
First two, I didn't redo them.
That's-
They were already in the packet. I did look at it. It's the same parent.
The second one was slightly different because the second one in the book is just an x minus 4 plus 1, and in the packet it had a 2 in front. The first one was exactly the same, yes. So are there questions from the 6 problems in the book that you'd like to go over? So it was this graph, it's just there were transformations that you were asked to do to that graph. So would you like to see any of those? Virginia? Yeah. So number 25 says negative f of x minus 1 plus 4. And I'm going to grab the points here. Negative 2, 3, 1, 2, 2, 0. So, David, what's going on with this graph for number 25? How is it going to shift? So he said x plus 1. That means it's going to move to the right 1. It's going up 4, and the y is negative. So instead of negative f of x, that changes to negative y, and the plus 4 gets tacked on also with the y. Whatever's inside is changing the x. So, David, if we had a negative 2 and you're adding 1 to it, it becomes, the 1 becomes, and then the 2 is 3. And then your y values, make it negative and then add 4. Good. So those will be my new ordered pairs from the original 3 changing to the new 3 based off of making the y negative and adding 4 and then moving the x to the right 1. So if you plot these points, negative 1, 1, 2, 2, 3, 4. That would be the new graph.
Actually, what's going to
Any questions on that? So then 26 said 2fx plus 3 minus 1. So 2x plus 3 minus 1. So Ethan, what's going on with this graph? How's it moving?
x is 2x minus 3.
Okay, so x minus 3, the only thing that's happening to the x is we're subtracting 3. Because it's moving to the left. What about the y? The y is a minus 1, but this 2 also goes with the y. Because it's with the f. Anything that's with f of x has to change to y. So if you see an f, really that's saying 2y and then minus 1. So the outside numbers always go in the y column. The inside numbers are really the x, and it's the opposite to get your x. So if my original points are up here, Sarah, do you have the new points if it's x minus 3?
-5, -2, and
And then the y points multiply it by 2 and then subtract 1.
-5, 3, and
So just be careful where you're putting the number outside. It always goes with y. Anything outside should be on the y. Inside creates the x. Other questions? Hopefully the stapler has made its way around. Yes? No. So that's the stapler.
Oh, I'm sorry.
Oh, jeez, Grace. All right, so if you have your page stapled, make sure your name is on it and pass it forward for me.
Wait,
If you have questions on those graphs and you're still not getting it, please stop by and see me. You can still pass it in if you'd like, but please come by sometime and see me about those graphs. I know they are very different from things that you've graphed before. Yes, that would, yeah, you can just pass it up.
you guys think it would work?
You guys already got these, right? Yeah.
Okay, we're on the stage.
Oh, and you want-
Anybody else need a worksheet?
Oh my gosh, I was just saying that as I was getting up. I think we just stole that from this.
Well,
Anybody else need a stapler?
I do.
You wanna pass those worksheets or homework up then? Stapler, Sam needs it then as well, if you can pass it to him.
This paper fell off. Stapling on backwards. Yeah.
So we're gonna talk about domain and range today. Kind of taking a little side step here before we go back and talk about piecewise functions. If you look at the front of that page, the little packet that you picked up, there are 9 crazy looking graphs on that. Besides the first one, it's just a bunch of scatter plot points. So we are going to try and find the domain and the range of all these graphs. Tomorrow, we'll be using domain and range to create the graph. So you'll be given a domain and an equation, and we'll be actually coming up with graphs that look like this. So we're going to be still trying to stick with those strange looking graphs and trying to create them, not your ordinary lines, so not just a y equals mx plus b graph. And that's what a piecewise function is. It's like a bunch of equations that you kind of mash together to make a crazy graph. But just to review, this was a quiz question, which I will get back to you tomorrow, I promise. The quiz is from the linear regression. I just have 2 people that hopefully come tomorrow morning and make that. So if we have the domain, what is the domain of a function or the domain of an equation? Aaron. Yeah, the x values. You could also say it's the input values. We could also say it's the independent values. But it's all of the x values represented in the graph. So whatever your graph, it's always kind of based off the graph. Whatever your graph is showing you, the x values in that graph would be the domain. So the range then would be all the y values of your graph. Now each graph is going to have a different range or a different domain. They're not all going to be the same. Unless it's a function that is a family of functions. Then their domain and the range might be similar to each other. But these graphs here, I mean, they're all just crazy looking graphs. So we're going to see if we can try and think about how to find the domain and the range. Start it off with points, because it's easier to think about domain and range with points than it is to try and look at a pentagon or a crazy line here. I don't even know what you would call that. It looks like half of a trapezoid that doesn't have like the base on the top of it. So if we have a set of points, when you are looking at the domain, you're just finding the x's of those points. When you start with domain, you always start on the left of the graph. We said it was the x values. X values increase. So starting on the left, working your way to the right, you want to list them in order from least to greatest. Same thing with range. You're going to start with the lowest value at the bottom and work your way up. So domain is always reading from left to right. The range is always reading from the bottom to the top. So make sure you try and get in the habit of looking left to right, bottom to top. So on this one here, this set of points here, I just want you to list the x values. So whatever point touches an x is actually part of the domain. So Anthony, can you give us the x values of all those points?
-2,
Okay,
1,
good.
1,
Okay, so we won't write it again, but yes, there is another one.
and
-3, and then there's one more that's a little trickier to see. 4, good. So from the left, the first one's at -3, then we have -2. We have 2 of +1, but you only need to write it once. And then the last one is at a 4. This is a set of points representing the domain. We're going to put those little squiggly guys around those squiggle brackets, to show that that group is contained together, that they're not separate points, but all of them together make the domain.
So I have 2 questions.
Yeah.
We don't write the 1 again, but
You
then
don't write the one again. Once it's there, it's there.
when we're graphing it, how would we know, if let's say we have 5 range points but 4 domain, how would we know that we have to graph the 1 again?
You would not, like, there's no way for you to know. I mean, yes, you're going to have, so you would know that you'd have to have another. Can you give me the range so then I'll finish my sentence? Sorry.
-4, -2, 0, 3, and 5.
Okay, so because the range has more than the domain, you know that one of those domain numbers have to be repeated, just because there's 5 here versus 4. So 5 tells me that there has to be 5 points. But there's no way for you to know which one of them would be repeated without being like a mapping diagram or the actual points being listed separately. So I can't take a domain and a range listed like this and try and graph it
Okay.
without having more information given. Other questions? Is this a function? No. Right here, vertical line test. Remember, the vertical line test determines if something is a function by drawing vertical lines. If one vertical line passes through a set of points twice, 2 points on the same line, then it's not a function. All right, so that one was pretty straightforward because we just had a set of points. The rest of the graphs are lines that are connected in some way. And we're going to see if we can look at the domain and the range. So when you're looking at it, you need to pick the first point on the left, the first x value that it starts at. And then you need to pick the x value that it's stopping at on the right. So where does it start? The graph is going to move, it's going to do something, but where does it stop? That's really what you're looking for the domain. Starting point and ending point, because it includes everything in between. The graph goes from one to the next. So Isabella, what's the starting point of this pentagon on the x?
Okay, so the starting point would be 0.
How about x?
Okay, so the starting point would be -3.
Right, so the point farthest to the left of the x. So the farthest x value is at -3. So I'm gonna look at the graph and pick the x that's the farthest to the left. And then Isabella, as the graph moves, what's the farthest right x value that it's finding?
3.
3, a positive 3. So my graph goes from negative 3 to positive 3 for the domain, which we said was the x value, so I'm going to put an x in there. And we're going to create an inequality so that the inequality shows that it goes from one value to the other. Caitlin, how would that inequality look?
Negative 3 is less than or equal to x is greater than
You're close. It actually would be less than or equal to 3 then as well. So if I'm reading this, if you start in the center, so this is a compound inequality, starting in the center at x, if I go left, it says x is greater than or equal to negative 3. That would be the left side of my graph. That has to be bigger than negative 3. But x is also less than or equal to positive 3, and that's the right side of my graph. Reading it, when you have an x in between two values, that says that all those values, my x has to be in between them. So x represents all the values in between negative 3 and positive 3. As long as you start with your farthest left value and end with your right value, the inequality signs will always face in the same direction. They will never change as long as you start with least and move to greatest. So the inequalities will always face that same way. They'll open to the left. Questions? So how about the range? If you go from the bottom to the top, Sarah?
Negative 4 is less than or equal to y, which is less than or equal to 3.
Good. So the least number, the bottom number for the y is negative 4. And then it slants a little bit, it slants again, and the peak of it, the max, is a positive 3. Sarah, is this one a function? No. Another one that's not a function. Questions? Alright, so let's look at number 3. Again, get your first x value, and then where does it move to go to the last x value? Sam, what do you think for the first x value?
Negative 4.
Okay. And what's the last x value?
Infinity.
Good. So the graph has an arrow on it. It doesn't have a stopping point. And the arrow means that it's going to continue to go up, but it's also going to continue to stretch further and go to the right. And when something goes on forever, that's that little infinity symbol. It's your snowman or your 8 that fell over. Snowman's starting to melt, so it falls over in your yard. We need to put some inequality symbols in the middle here, Sam. Do you know what's going on with the inequality symbols?
Yeah. Negative 4 is going to be less than or equal to x.
Why do you say less than or equal to?
Because there could be another point there. Like you could put another point on. I don't know.
What's going on with this point right here?
Oh, you don't know actually. It's less than.
Why?
Because it's not a closed circle.
Yeah, it's not a closed circle, so that's just going to be a less than next to the negative 4. Open circle means that point doesn't exist in the graph, but it can get really, really close to it, so it has to just be less than negative 4. The other side, infinity, there is not a number attached to infinity. We don't know what that number is. So you can't include an equal to with infinity because infinity goes on forever. There is another way that you could write this. Does anybody know another way that I could take this same thing Sam told me, which is perfect, but there's a different way that we could write it. Virginia? And I'm going to just flip it around. You could have also said x is greater than negative 4. Because it just goes on forever and ever and ever. There isn't a stopping point. So you could have said just x is greater than negative 4. Either one of them would be correct. They both mean the exact same thing. So if you prefer having a starting and a stopping point, that's fine. Then just continue to write them with two numbers on either side of x. But they mean exactly the same thing. Questions? So for the range, Tyler, what does it look like the range is doing?
3. Wait,
What's the y value that it starts at?
3.
You're giving me x. Oh, you're giving me this point. What's the lowest y value? I'm sorry.
Oh,
What's the
1.
lowest y value? 1, yes. Okay, so the lowest y value, yes, it starts at that point, but now we're looking vertically, so we want to get the lowest value of the graph, not necessarily starting point on the left. And then Tyler, how high does it go? Infinity. So again, that one goes to infinity. Is the 1 a point of the graph?
Yeah.
Yes, so that gets the equal to, and then the infinity does not. So you could have also said y is greater than or equal to 1. You could have written it like that. Because if it goes to infinity, it's going to go forever and ever and ever. Is that one a function? Does it pass the vertical line test, Paige?
It does.
It does. Now, what's continuous mean? We've been trying to work with those words. Continuous, discrete. It says if it's a function, state if it's discrete or continuous. Is this discrete or continuous? Tyler? It is continuous. Continuous means that it does not stop. It doesn't have a hole in the graph. If there was another open circle at one of those points, then it would not be continuous. An open circle means that that point isn't there, it doesn't exist. But if there isn't, so when I'm starting on the left, I can just continue the graph. So this would be continuous. Discrete. Graph 1, if it was a function, would be discrete. Discrete are just the points, the scatter plots. That's discrete. If it's not discrete and it's not continuous, then you would say it's neither. So see if you can do the next 3, and then we'll talk about them. The line is a little different, the line in the middle. So try and see if you can think about how to write the domain range for the line. So did you do anything like this in Algebra 1? No. I've never taught Algebra 1, so I don't really know exactly how in depth you go. I know you talk about domain and range a little bit, but I'm assuming that you're not really interpreting it to the full extent with different graphs. Ethan, what do you think for the, not quite a circle, it's actually called an ellipse. What do you think for that? Oh, we'll call it an oval shape for the domain.
I said it's x is greater than or equal to -2.
Good.
Less than or equal to 2.
Good. How about the range, Ethan? You did a good job there. What's the range?
Y is greater than or equal to 0. Less than or equal to 3.
Is it a function? No. Excellent. Thanks. So, number 5. It's a line. We know lines are functions. This is also continuous. Anybody want to take a shot at the domain, Virginia? X equals y plus 2. So that would be giving me a formula for how you could relate them. But we want to say something else, like just explaining all the numbers that it would touch. Aaron?
Just infinity.
So he said, would it just be infinity? Because the left continues forever, and the right continues forever. So it goes on from a negative infinity, it goes to positive infinity. But there is a way to actually write this instead of saying negative infinity to positive infinity. And you can't just write the infinity symbol. Okay?
Is it x is greater than plus or minus infinity?
So she said you could say x is greater than plus or minus infinity. But there is a special letter. Or like 3 words, actually. You could say 3 words that go along with it. A special letter or 3 words. Paige, what were you going to say?
For some reason, I feel like the letter is either an A or an R.
So it is an R. It's like a fancy R. Like in English, you have that paragraph symbol. This is the paragraph symbol in English that says, hey, you should have had a new paragraph here. In math, we have our own symbol because got to make sure that we have symbols too. Does anybody know what that symbol means?
I'll remember.
Yeah, all real numbers. So instead of saying from negative infinity to positive infinity, we could say all real numbers. So every number on the x, the line will touch. Every number on the y will touch. You don't have to write that R perfectly. It's like a scripted R, but do the double line, the R over it, or you could write all real numbers. That also means negative infinity is less than y is less than infinity. So any of those are acceptable. Questions with that? So number 6, we'll stop with this one here. What is the domain of number 6? Ethan? So the domain is all real numbers because it's going to touch every x. It's going to continue to get wider and wider and wider and stretch to the negative and stretch to the positive values. Julia, how about the range? It's the lowest value.
-5.
-5. And how high does it go? Yeah, it goes to infinity. So you could also say y is greater than or equal to -5. It's going to go on forever vertically. It just continues to get higher and higher and higher. Is that one a function? Yes. Passes the vertical line test. It's continuous. There are no breaks or holes in the graph. If there was a hole somewhere, then it would not be continuous. You'd just say it's smooth. So you don't have to finish the 3 problems on there, but if you open it up like a book, there are a ton of problems graphing in there, and I know that there are a lot, but I really need you to be solid with domain and range. They do not take a lot of time, and there is no work. Okay, you're not doing any steps at all. So I do want you to do both of those pages for homework tomorrow. It should not take you very long. If it does, stop. Come see me tomorrow morning if it takes you a long time to work those out, because I want to be able to work with you and explain them to you again.